Hello, welcome to Tennessee's At-Home Learning Series for Math. Today's lesson is for all our 7th graders out there, though all children are welcome to tune in. This lesson is the 6th in our series. My name is Kayla Anderson, and I'm an 8th grade math teacher at Rocky Fork Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website at www.tn.gov/education. If you don't already have the student packet for this lesson, you can find it online at www.tn.gov/education. You can still tune into today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about things we learned previously. Today we will be learning about adding and subtracting with integers in mathematics. Before we get started, to participate fully in our lesson today, you will need paper, pencil, and a surface to write on. Okay, let's begin. So if you will take a look at this first couple of expressions that we have here. Let me get rid of myself. So in this lesson, we will learn about subtracting integers and decimals. Remember that integers are positive numbers, negative numbers, and zero. The set of integers does not include fractions or decimals. Let's think about these 4 expressions that we have here. Remember that an expression does not have an equal sign, whereas an equation does. How are these expressions the same? Okay, so let's simplify these expressions. So I want you to first start with A, and I want you to simplify 14 minus 9. That's right, it is 5. This one is pretty straightforward. 14 minus 9 is 5. Okay. Now I want you to simplify B, negative 14 plus 9. How is this different than expression A? Notice that in A, 14 was positive and we were subtracting 9. In B, 14 is negative and we are adding 9. So negative 14 plus 9 is negative 5. Take a look at C. 3 plus 2. Go ahead and simplify that. That's right. It's also 5. Again, this one is straightforward. How about D? Negative 3 plus negative 2. What do you think? How do we think about adding 2 negative numbers? They are both below 0, so the sum will also be below 0. Negative 3 plus negative 2 equals negative 5. So all 4 of these expressions either equaled 5 or negative 5. How are these expressions different? A is the only subtraction expression. B is the only expression with a negative integer and a positive integer. C is the only addition expression with 2 positive integers. D is the only addition expression with 2 negative integers. We just reviewed how to add positive and negative numbers. In this part of the lesson, let's focus on subtracting positive and negative fractions and decimals. Let's think about diving. A diver is standing on a platform that is 10 meters above the surface of the water. The bottom of the pool is 5 meters below the surface of the water. Can you draw a sketch of this situation? How would you label it? How would this look on a number line? I'm going to pause for about 30 seconds to let you draw a sketch of this situation and a number line, and then we'll come back together and solve this one. Okay, so for my sketch, I'm going to start out with the surface of the water, and I'm going to call that 0. And then it says that there's a diver that's standing on a platform, so we'll draw our platform up here. And that platform is 10 meters above the surface of the water. So from the surface to the platform, 10 meters. Then the bottom of the pool is 5 meters below the surface. So I'm going to draw the bottom of the pool. And I know that because that's 5 meters below the surface of the water, I'm going to represent that with a -5. Because if the surface is 0 and 10 meters above is a +10, then 5 meters below I'm going to represent with a -5. Okay, so this +10, one more time, what is that representing here? Good, remember that that's because the diver is 10 meters above the surface of the water. Okay, and then here this -5 is representing what? Good, the bottom of the pool. So if I'm showing that on a number line and I've got a vertical number line here, does this vertical number line look similar to the sketch that we've drawn? Yes. So on the number line again, notice that the 10 is positive, but that the 5 is negative. And why is that? Good, because the 10 meters is above the surface of the water, which is 0, while the bottom of the pool is 5 meters below the surface of the water, and we represent 5 meters below the surface with a -5. So if the diver dives from the platform here, touches the bottom of the pool, how far did he dive? In other words, how far is it from the platform here to the bottom of the pool? Oh, excuse me, from the platform, which is here, to the bottom of the pool. How can we represent this situation with an expression? I want you to write an expression that you think will represent this distance from the platform and then touching the bottom of the pool. From the platform to touch the bottom of the pool. What expression can represent that? So there are two ways to think about this. We could look at our picture and say that the 10 meters plus another 5 meters is 15 meters. So 10 meters from the platform to the surface plus another 5 meters to the bottom of the pool is 15 meters. Or we could say that finding distance between two numbers on a number line is the difference between the two numbers. So if we're thinking about our number line again, which was really similar to our drawing here, if we're thinking about the distance between 10 and -5 on this number line, it's going to be the difference between them. If we're using that line of thinking, then we're going to have 10, which is where the platform is, take away, which is what difference means, and then the -5 here, which is from the surface of the pool to the surface of the water to the bottom of the pool, equals 15. Which of those two ways were you thinking? Did anyone get 5 meters? Did anyone say 10 take away 5? 10 take away 5? Does a distance of 5 meters make sense in this situation? If you said 10 take away 5, what was your misunderstanding? We can think of distance as always being positive. We do not normally think of distance as negative. For example, if our car is in reverse, we don't think we are going a negative distance. Distance is measured in positive numbers. This is why we can look at our drawing and say 10 meters plus 5 meters equals 15 meters. But what about distance on the number line? The same reasoning applies here. To show the distance is positive, we can use absolute value. Have you heard that term before? If so, we are going to review. If not, we're going to learn all about absolute value today. We will come back to this problem in a few minutes. For now, let's talk about absolute value. So I'm going to pause for 20 seconds, and I'd like you to write everything that you can remember about absolute value. We know that absolute value is a number's distance from 0 on the number line. For example, 10, which was the height of the platform, is 10 units from 0, so the absolute value of 10 is 10. We indicate absolute value using vertical bars. So the absolute value of 10 is 10, because 10 is 10 units away from 0. -5 is 5 units from 0. So the absolute value of -5 is 5. This Freyer model can help us organize our thoughts. So take just a second, go ahead and draw yourself a Freyer model. Okay, and we're going to fill this in. So what is absolute value? We just had a conversation that absolute value is a number's distance from 0 on the number line. Okay, well, what are some things that we know about absolute value? First, absolute value is always positive. Second, it is indicated using vertical bars. And those vertical bars look like this. What are some examples of absolute value? Well, the absolute value of 4 is 4. Good, because 4 is 4 units away from 0 on the number line. How about the absolute value of -4? You're right, that's also 4, because -4 is 4 units away from 0 on the number line. How about the absolute value of 0? The absolute value of 0 is 0. 0 is 0 units away from 0 on the number line. How about some non-examples of absolute value? A non-example of absolute value would be something that equals a negative number. The absolute value of 4 is not -4. Remember, in our notes here, we wrote the absolute value is always positive. Okay, I'll pause for you to continue copying down any of that you still need. Okay, let's go back to our diving example. From our drawing, and here's the problem again, and we have our drawing here. So from our drawing, we found that 10 plus 5 equals 15. From the number line, here's our number line again, we found that 10 take away -5 also equals 15. That means that 10 plus 5 is equal to 10 take away -5. Because we got the same number for each of these expressions, 10 plus 5 equals 15, and 10 take away -5 also equals 15, it must mean that these two things are equal to one another. Is that always true? Yes, it is. We will do some exploration with other expressions, but first, let's revisit our misunderstanding that 10 take away 5 equals 5. So remember, we had a misunderstanding and we said we wanted to talk about the reasonableness of this misunderstanding. Is it reasonable to get 10 take away 5 equals 5 from this drawing and for our scenario? This is not reasonable because the distance from the bottom of the pool, which is here, to the surface of the water is 5 meters. And the diver is going to go a distance of 10 meters before he even hits the water. This must be more than 5 meters. Therefore, 10 take away 5 is not the same as 10 take away negative 5. Let's practice. The top of a molehill, let me get this out of the way. The top of a molehill is 4 inches above ground level. The bottom of a mole's burrow is at 29 inches relative to ground level. What is the distance between the top of the molehill and the burrow? Show your work. I'll pause now for you to work the problem. Did you write 4 plus 29 equals 33? Good. If we think of ground level as 0, we can think of the top of the molehill as 4 inches above and the bottom of the burrow as 29 inches below. Then we can add the absolute values. So if you need a visual to go with that, if we think of the ground level as 0, we can think of the top of the molehill as 4 inches above, and the bottom of the burrow as 29 inches below. Now remember that because it's below, that would be a negative 29. However, the absolute value of negative 29 is 29. And the absolute value of this positive 4 is 4. So if we add those absolute values, the 4 plus the 29, we get 33. Did you write 4 minus negative 29 equals 33? This works too. If you think of the distance from the top of the molehill to the bottom of the burrow, the distance is the difference. And remember that difference means subtract. Either way of reasoning is correct. Here's another example. The city of Jericho in the Jordan Valley sits at an elevation of about 846 feet below sea level. The city of La Paz in Bolivia sits at an elevation of about 11,975 feet above sea level. What is the difference in their elevations? I'll pause now for you to reason through this and think about your answer. If we assume that the sea level is at 0, we know that above sea level, here, can be represented as a positive number, and below sea level, this is below sea level, this is above. This is our above sea level, and below sea level, this one, can be represented as a negative number. So we can write 11,975 minus negative 846, or we can write the absolute value of 11,975 plus the absolute value of negative 846 using absolute value. Either way, the difference in elevation is 12,821 feet. So keep in mind that either way of reasoning is correct. You can take the above sea level and subtract the below sea level, or you can think about the absolute value of the first number plus the absolute value of the second number. Either way of reasoning is correct, 12,821 feet. Okay, let's look at an example of non-integers using a number line. So explain how you can use a number line to find the distance between 1 and 5/10 and negative 2 and 75/100. So I'm going to pause so that you can use a number line to find the distance here. Okay, so here is my number line with 1 and 5/10 here and negative 2 and 75/100 here. The distance from 1 and 5/10 to 0, distance here, is a distance of 1 and 5/10. The distance from 0 to negative 2 and 75/100, this distance, is a distance of 2 7/500. So I can write 1 5/10 take away negative 2 7/500. 1 5/10 take away, because remember we use difference to find distance, negative 2 7/500. Or I can use absolute value. The absolute value of 1 5/10 plus the absolute value of negative 2 7/500. Are these two expressions the same? Yes, both of those expressions will equal 4 25/100. This means that the distance from 1 5/10 to 0 is being added to the distance from negative 2 7/500 to 0. So we're actually taking the distance from 1 5/10 to 0. That distance is 1 5/10. And we're adding it to the distance from negative 2 7/500 to 0. And again, that distance is 2 7/500 to give us the 4 25/100 as the distance between these two numbers. Now what I'd like you to do is find the distance between negative 1/2 and 3 1/4. What strategy did you use? Did you use a number line? Here's a number line. We could count the distance. Remember that we're using fourths here. So we could count this distance of how many fourths. So here we are at negative 1/2, and here we are at 3 1/4. And because we're using fourths, we could count the number of fourths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 fourths as the distance there, which is the same as 3 3/4. So just counting from here to here, counting by fourths, we counted 15 fourths, which is the same as 3 3/4. We could also write ourselves an expression, 3 1/4 minus negative 1/2. Remember, when we're finding the distance, we use difference, which means subtract. So 3 1/4 take away negative 1/2. We will need to find a common denominator here. So for negative 1/2, we can rewrite that as negative 2/4. Negative 1/2 and negative 2/4 are the same thing. And so once we have our common denominator, 3 1/4 take away negative 2/4. Remember that this is what our new problem would look like once we have a common denominator. Or we can use absolute value and say the absolute value of 3 1/4, which remember is the distance that this number is from 0, plus the absolute value of this negative 2/4. So the absolute value of 3 1/4 is what? Well, it's how far is 3 1/4 from 0? And it is 3 1/4, plus the absolute value of negative 2/4, which is positive 2/4. And adding those together, we get 3 3/4. Okay, so great job today, everyone. Today we reviewed what it means to subtract integers and non-integers. We used number lines and absolute value to help us reason. After the video, you will have some problems to practice on your own. I will show you the independent practice problems now, or you can find them in the student practice for this lesson posted on our website at www.tn.gov/education. Good luck and do your best. So here's what that independent practice looks like. So for your independent practice, it says, think about this situation, draw and label a picture, draw and label a number line, use these to reason about the problem, write an expression to represent the problem, and use your expression to solve the problem. When people travel down major highways, they can use mileposts to calculate distances. Mileposts mark the distance along a highway, starting at one end and going to the other end, or to the point where the highway crosses a state border. Depending on which direction a driver travels, the numbers on the mileposts might increase or decrease. For example, if a driver has just passed milepost 137 and wants to eat at a restaurant at milepost 60, the driver knows that the distance to the restaurant in miles is equal to the absolute value of 60 minus 137, or 77 miles. Question A. You are at milepost 345 and you notice the next milepost is 344. Are the miles increasing or decreasing? Question B. You are at milepost 345 and your next stop is at milepost 221. What is the distance you will travel to your next stop? Question C. You are at milepost 4 and your next stop is at 56. What is the distance you will travel to your next stop? I enjoyed reviewing, adding, and subtracting integers with you today. Thank you for inviting me into your home. I look forward to our next lesson together in Tennessee's At Home Learning series. Bye.